Hi. Yeah, so I was going to follow Ross, and I probably would have had a bit of synergy around the space, but let's do things in reverse anyway. So yeah, I mean, this is a really good opportunity to start talking about these things and start talking about computational design. And you know, for me, in particular, I'm really interested in how practice is changing and how architectural practice is changing. And I like to say, you know, we're reconfiguring the way it works. And I'm seeing this firsthand quite a lot. So, you know, talk about this expanding field of design computation, which is not just about, for me, a kind of specialist sitting in a corner or kind of working on problems and solving them and kind of distributing them back out to the practice. It's actually about that type of thinking, that type of practice becoming part of the architecture itself and the way that we do the work that we do. Yeah, so I guess a little bit of background about me. I work for Cox, so I'm the National Design Technology Lead of, and I operate the innovation portfolio. There are 3 of us, so there's someone doing strategy, there's someone doing operations, which is more like your management thing, and the 3 of us kind of form the National Design Technology Leadership Group of Cox. And at the same time, I'm also a teaching associate at UWA, so some people I might recognise, you might recognise me. But yeah, I've been working in and around this computational design space, either as a researcher, as a teacher, or as a practitioner for a long time. And what I'm most interested in is, I guess, the framework around this space, this computational design space. And so what I'm going to talk about is less about the things that I'm doing as in process, and more about, I guess, attempting to set the scene for what I hope that this group will be able to start to discuss and the kinds of things that we'll be able to talk about as a collective. 4 things that I'm going to talk about. So the digital in architecture, which is, I guess, a little bit of a background piece and kind of thinking about how we got to where we are, some trajectories, and kind of where we're going from here, where we might be going, some examples of things in practice, including some of the things that I'm doing, and a little bit of a question about, okay, so given this, what next and how do we get there? So I guess one thing to kind of talk about is really that architectural practice. I'm going to talk from my experience as an architect. I know that there are many people here who aren't architects, but my experience is primarily within architecture. And we talk about this idea of this room, you know, architects sitting in a room, drawing, all that kind of stuff. And mid-20th century, this is what it looked like, drawing boards, quite archaic, of course. And then we talk about the early 21st century, and it's kind of the same, right? A lot of people are still working on their own, looking at a screen rather than a drawing board. But, you know, we pack people in. They're people who have all got kind of similar skill sets, they come from similar backgrounds and are doing the same kinds of things. So things haven't really changed in that way. And I see right now that we're at a bit of an inflection point where technology is advancing really, really quickly, faster than it's ever advanced before. You know, projects are getting more complex. The time frames are getting tighter. Fees are getting smaller. All these kinds of things are happening. So we need to make a change, or a change is coming, let's say. And in many ways, practice isn't really changing. Despite all of these things, and to me it makes sense actually, because whilst we talk about, you know, the computer age and the digital age and where things have, you know, and that we are now all in this digital age, even in the mid-20th century, we were still doing the same things. We were talking about drafting machines. We were talking about parametric design. These same questions we're having today were still being asked and being developed. So this is 1963. On the left here is the iTech electronic drafting machine, one of the first electronic drafting machines, and on the right here is Ivan Sutherland's Sketchpad parametric design tool developed out of MIT, which kind of started the CAD revolution in some ways. And then, you know, this kind of discussion or this kind of exploration continued. We've got on the left here Nicholas Negroponte's architecture machine, which is one of the early forays into thinking about generative design, or thinking about designing using different types of tools, in this case linguistic tools, so kind of talking to the machine and trying to design a machine that can interpret intent, not necessarily via what you draw. And on the right, you have the generator project, Cedric Price and John Fraser, which is kind of developed out of this. If you know the generator project, it's about architecture that can reconfigure itself based on the actions of the people who inhabit the space. Prototypes, of course, but these discussions have continued. And that's kind of what we're doing today, right? We're talking about generative design. Autodesk are trying to sell us generative design as a new thing, but we have been doing that. And and this diagram here, I'm just thinking a little bit about not the ecosystem, but more that, yes, we've been developing tools and we've seen this kind of move into the digital age where we're engaging with computational design tools or with automation, with AI, and we're doing it in kind of like a vertically stacked way, in that we're operating within our own disciplines, right? We're trying to make what we already do faster. We're trying to make the things that we already do more efficient, more productive, but at the end of the day, we're still doing the same things. And we're still working within the same disciplines, and when we need to talk to other disciplines, we do, and we try to solve those problems when we get there. But we're still kind of siloed in that space. And this, this is how I work, and yes, this is Grasshopper, and there are tons of things here. I've extended my own toolbox, but it's really my own toolbox, right? None of this stuff here is really enabling me to better communicate with other people. And at the same time, we've entered into this thing called the Fourth Industrial Revolution. Many people have probably heard about it, or, we're in it, so it doesn't really matter whether you've heard about it or not. Industry 4.0, and really what it's characterized by is this idea of cyber-physical systems, where we are working with shuttling information from kind of our intent or via interfaces to machines, and those machines are doing the work for us. And it basically means that we're operating in a space where we are controlling the means and the mechanisms by which data is being moved from one position to another position, or one party to another party. And when we start to work in this space, we start to become more disconnected from the actual output of our work. We start to become more disconnected from the kind of where the things that we design go, which means we need to be more in control of where those things are going, or more in control of how those things are being delivered. This kind of moves on to this idea of buildings as data. We all know about this, and this has been understood for a long time. But I think we've really started to see the rise of this idea that what we're doing isn't about the end product as a built object, so much as it is about controlling the data that enables that built object or enables the built environment. And in fact, if we don't have control of that data, we don't understand what that data is, then we're going to be quite lost. And I think a lot of architectural practices are still grappling with this idea. They're still grappling with what the tools they use mean in relation to the things that they design and the things that they do. And whilst I guess we've been moving slowly into this space, and I'm sure many practices or many people here who might work for practices might still be using AutoCAD or more traditional drafting tools, and they might even be using Revit, and they might be using Revit to do things the way that they've always done them, but maybe slightly faster. But at the end of the day, they're still designing drawings that will eventually turn into buildings or turn into other things. So we're still doing things kind of the same way. But while we've done that, other companies have seen the opportunities inherent in data and the opportunities that this enables for us. We've got WeWork here. You all know of WeWork. Tech company, well, they didn't start that way though. So in 2009, they were a co-working company. They were really really clever in the wake of the GFC. They bought up a lot of cheap real estate. They started reselling it at higher rates per square meter, but in fact it looked a lot cheaper to the consumer. And they could have done this. They could have optimized co-working. They could have kept going in that way. They could have thought, well, this is our business and we're going to make it great. 10 years later, they're not co-working anymore. They're now the We company. They're doing co-working, they're doing co-living, they're doing education, they're doing fitness, they're doing all these kinds of things. They're all building towards a full service design and construction company. And to enable that, they've acquired all these other companies. They've acquired K-Sync, who were one of the first companies to popularize this idea, or I guess leverage buildings as data. So they're architectural data-driven design and research company. So they acquired them, they saw that opportunity. They've acquired Meetup. So that's, Dan invited you all here using Meetup. So we work capturing all that data and understanding the kinds of things that people are interested in, how many people are, and they're building business models based on that information. Team, which is a workplace software analytics, software Euclid, Flatiron School, coding, Fieldlens, construction coordination, Conductor, targeted advertising, so don't be surprised if you start to get targeted advertising after this. But what this means is that they've built a company that is the developer, the real estate agent, the tenant, the lessor, the architect, the facilities manager, the contractor, the whole lot, right? They've built this entire company, and they're coming basically well, they want a piece of the pie, really. They've seen the opportunities in the built environment and in the kind of technology we're doing, and they're not waiting. I don't want this to be scary, but another one is Sidewalk Labs, Alphabet. Google acquired them a few years ago. Again, Google saw the opportunity. They saw that if data is what everyone's after, data is the most valuable thing, then yes, they can access it through our search histories, through our phones, etc. But the built environment is actually one of the richest interfaces for data, right? How people use space, how people inhabit that space, how people meet in space, how people live. So they've actually started developing they're developing a master plan for a city in Toronto, and their kind of strategy was released 2 or 3 weeks ago, and there's a massive section in it on innovation in buildings and housing. You know, that's a massive part of what they're proposing, and they're proposing a system of building, a system of construction. Again, digital fabrication, modularization, mass timber. You know, they're hiring computational designers, they're hiring architects, they're hiring engineers. They're interested in bringing it all in-house. What's interesting is this starts to talk about the types of people, I guess, and some of you are those people who are entering into the industry right now, and what they're going to expect in the future and how the industry is going to change. This diagram here talks about how people have been moving around within the computational design community in the US, which is actually a small community, right? But they spread. This is people who have spoken or been guests on the Archelize podcast, which doesn't run anymore. And those people talked about computational design, and they were all at particular practices, but they've been moving through the industry. And as they've moved through the industry, they've imparted things and taught people, and they've started to kind of infiltrate practice, and they've started to build these large communities. And what's actually happening, and this is kind of an image put together by Brian Ringley, who at the time was working for Woods Bagot. But what was happening was they were all starting to get sucked up by WeWork. So WeWork was seeing the potential and the opportunity in that space. Funnily enough, Brian Ringley is now at WeWork, as are probably half of these people to an extent. So, you know, it's kind of terrifying, but it's an incredible opportunity at the same time, and it definitely demonstrates the value of the types of things that computational design thinkers and those who are able to speak the language of computational design are able to access. So given that, what are some of the trajectories? What are some of the scenarios? So there are 3 things that I see, and many others people do see as well. I see this idea of we've got the Superusers, we've got the startups, and we've got vertical integration. And these might be some scenarios for the future. Superusers is the title of a book by Randy Deutsch that was released not 2 or 3 months ago. He's a researcher, academic, and writer, and past practitioner in the US who's followed the change in the architectural industry for a long, long time. probably over 20, 30 years, but over the last 10 years he's really started to pay attention. He's written a few books, and his latest book about superusers has identified this massive change in the types of skill sets that people need going forward, or are going to need, and the skill sets that he's identifying in all the new types of practice leaders, be they at WeWork, be they at Zaha Hadid, be they at Baggett, etc. And this quote kind of encapsulates that way of thinking. So, there's this huge shift in which, and that shift is more comfortable to some than others. We've also got increased productivity that we need, increased profits, all those kinds of things that are really important to our survival. We all need to get comfortable with it, and we're about to see incredible changes in our profession and industry. And it's actually superusers, who he dubs this whole group of superusers, who are the ones that will get us there. And so what is a superuser? Well, he defines a superuser by these 10 C's, he calls them. So these 10 characteristics. And I'll go through them. So curiosity. Curiosity is they're people who are interested in finding things out. They want to know more. They're contextualizers, as in they are able to understand how the work that they do fits in to a larger scheme, to a larger framework. They're connectors, so they're able to identify things and bring them together, be they people, be they technologies, be they groups. They see the opportunities via connection. They're communicators. They know how to talk to each other. They know how to share ideas. They don't keep things to themselves, and they're willing to work with other people, which means they're also collaborators. They want people to help them, and they want to help others. They're open about what they're doing, and they're willing participants in that. They're capacitors. They're capacitors in that they are able to unlock the potential in other people, right? They're able to identify that, and they're able to unlock it. They're continual improvers, so they're not just happy with how things are. They want to make things better, whether it's faster, whether it's more efficient, whether it's just more aesthetically pleasing or more effective, all those kind of things. They're also concentrators, so they draw people to them, and they build concentrated pockets of excellence. They know how to build groups that are more powerful together than they are apart. They're also computational thinkers, so they think computationally. They see problems, and they think about how they can attack those problems using computational processes, whether it's via doing it themselves or understanding how to actually to leverage the talents of those around them to do that work and do that effectively. And they're also coders. And again, they may not be software programmers, they may not be doing writing C# and things like that, but they understand code, they understand how it fits within the work they do, and they're literate in it. And of all these 10 C's, and Randy makes a point to mention, 9 of them are actually soft skills. It's not actually about what you can do. It's actually about how you do it and how you can communicate with those around you to enable the work to be done, right? And so, for us and for me, core is computational thinking, but they're all really important. And I'm also identifying that a lot around Cox, and we've got some of the best computational designers around who remain kind of hidden within the practice, but they all exhibit these kinds of traits. They are, whilst they are good at coding, it's all the other things that make them really valuable. The other scenario is this idea of startups and spin-outs. So if you think about a superuser, and you think about what a superuser might want, when they come into a practice, they graduate, they come into a practice, they've got this skill set, they've got this drive, and a lot of traditional practices aren't really set up to actually to foster those types of people, right? They want to do more, they want to do better, they don't really want to do things the way that they've always been done. So there's this huge challenge that a lot of practices are having in keeping these people either happy, engaged, or just employed in their organisations. Hence, WeWork being able to capitalise on that, identifying that. But then you've got some other practices who are identifying that as well, and developing basically ways in which these people can be engaged and can be part of the practice, but still actually fulfill their kind of core goals as super users. So UN Studio have spun out UN Sense as a research group where they're actually alongside the main practice, they're building new research. Thornton Tomasetti, they've got an innovation incubator, they've got a computational design group, and from that they're also spinning out software packages. Canon Design has Yazdani Studio, Woods Baggett, Superspace, Digital Craft, amongst others. Bureau Happold have a smart space group from which has spun out the Buildings and Habitats object model, which they're developing as an open source tool for the entire industry. This is how these practices are keeping their super users engaged and within their practices. And then this kind of idea of, so we've got the spin-outs, we've also got the startups. So there's this website called AEC Startups that has been going for about a year, and it just lists all the startups in the architecture, engineering, construction space. And this list grows every single day. It's huge. These super users are leaving practices, and they're just going head first into this space. They're getting funding. So the great thing about this site actually is it not only lists the startup, but also lists how much funding they've gotten, when they've gotten the funding, whether they've gone broke, or whether they've been acquired, and all that kind of stuff. But it's really demonstrating this change that's happening in practice. Finally, you've got this vertical integration. You may have heard of Katera, a vertically integrated fabrication company. They used to be a logistics company. Now they're moving into bringing everything in-house. They want to do design. They've got logistics. They've got supply chain. They want to do fabrication. They want to do assembly. They want to do construction. The whole lot under one roof with the efficiencies to match. I think this is just the play. I don't think that's playing. There's a video here just scrolling down of the list of job ads that they've got going at any one time. There are thousands of job ads that Katera have at any one time. And these days, the bulk of those are software engineers, programmers, the whole lot. Let's decide what to work now. Moving. Again, we've got Lendlease. They're developer, but they're also starting to hire computational designers. They're moving into that space as well. They're seeing the opportunity. There are many others as well. So in terms of architectural practice, there are a couple of things. So this is a couple of examples of how other practices or other multidisciplinary practices are working within this space and leveraging the talents of their super users. Thornton Tomasetti are building kind of these democratic tools which expose computational expertise and computational thinking to their whole organisation. So these tools allow anyone in the organisation to upload a model and start to get completely automated kind of structural analysis. And anyone can access it. It's documented, etc. This is, they're doing a lot of this stuff now. Then we got someone like BVN. They're building web apps to communicate with their clients, with their stakeholders. These web apps are all these interactive spaces. So this one in particular is about the solar performance, so radiation around this building, and the client can open up that site, can zoom around it, can explode the thing, and they're doing a lot of this and they're exploring this as well. And you've got Shop Architects. This one's quite old now, but this was this is actually tracking I think the delivery of items from shop floor to, I think it's panels, shop floor to the site. A project architect can actually track that in real time, and they're building all these tools themselves, right? And then this is the kinds of things that their computational designers and their programs are doing day in, day out. This is another example of something that's happening as well. So this is KPF. This is a Plan Your Neighborhood app, but this is a web app that enables, in this case, probably an end user or a developer or any kind of stakeholder to actually manipulate options and see the results of the options in real time. That's not that interesting, but it's also enabling them to do things like perform simulations and analysis as well. So a user who's not the computational designer can access the computational design thinking, can access the outcome of that via these tools. So I see this as this real democratization, not just of design tools, but of the output of those design tools and thinking as well. So the computational designer at this point is, and again, you can see how this works with the idea of the super user. It's not just about doing the stuff, it's actually about being able to communicate what the stuff means to the people who actually need to make the decisions. Some of that's being built on the accessibility to open source tools that again have democratized simulation and analysis. So things that previously would have required really expensive software and a lot of expertise to use are being just offered open source, free for anyone to use, and are connecting all these complicated routines into much more simplified frameworks. And so computational designers and this is Ladybug and Honeybee that you can use in Dynamo and Grasshopper, and therefore Revit and Rhino, enable people to actually perform really high, really detailed analysis in almost real time. Which then is enabling things like this, which are this new emergence of PropTech. I was at a conference, I think 2 weeks ago, and there was a little dinner one of the evenings, and there was this PropTech event, and every single company there was doing something like this, which is basically, here's a map, here's a design, here's an analysis, and this is how it works. So the key here isn't so much the technology, so this is Archistar, Parametric Monkey, Shop, and I think this is ShapeMaker.ai. I think they just made 30 million euros in startup funding. The real thing here isn't actually the technology.